Remember this information. Whenever we have a number squared and then take the square root of it, the square and the root cancel each other out, and we're just left with the number. For example, if we have the square root of 5 squared, we cancel out the square with the root, and we're just left with 5. For example, the square root of 8 squared equals 8. Why is that? Because the root cancels out with the square, right? So we might think that if we have the square root of a squared, then this will simply give me a. We agree with that, but it turns out that what I'm saying isn't entirely correct. We would have to put some restrictions, because what happens? For example, if a is equal to minus 2, if a is equal to minus 2, then I have the square root of minus 2 squared. If we suppress it, then it's going to tell me that the answer is minus 2. But the answer to this operation is not minus 2. The answer is 2, and look, let's put it in the calculator so you can see. So we enter square root, open parenthesis, enter minus 2, close parenthesis, and raise it to the power of 2. Then we hit execute. It's telling me the answer is 2, not negative 2. Why is the answer 2 and not 2? Well, it's because what I have to do first is solve the square, and then I'll take the square root. So here I would have the square root of negative 2 squared would have to be the same as the square root of that negative 2 squared, which is equal to 4, and now the square root of 4 is equal to 2. So this expression we have here, when can it actually be useful for me? Well, it's only going to be useful for me when a is greater than or equal to 0. That's it. So let's write square root of a squared equals a, but only if a is greater than or equal to 0. Ready? With this restriction, now we can use this equality. Let's see. Let's solve these exercises. I want you to notice that in all cases, a is greater than or equal to 0. All right, let's solve the exercises. So it would simply be 3 here. It would simply be 20. And here we have 0, 4 done. We're finished. But now, what would happen if a is negative? For example, here we have the square root of negative 2 squared. Well, what we're going to do is simply take the absolute value of a, which in this case is negative 2. So here I have that. The square root of negative 2 squared is equal to the absolute value of negative 2, and the absolute value of negative 2 is 2. And we had already said that the result of this operation was 2, right? In general, we can say that the nth root of a to the n is equal to the absolute value of a. If n is even, pay attention. If n is even, that's why here I simply applied the absolute value, right? Because here, even though you can't see it, there's a 2. So that means n is even, so we can apply the absolute value, but only when n is even. When n is odd, we're going to do the following. Look, the nth root of a to the n is equal to if n is odd. And now we have these two equalities that we can use in the exercises. It's worth mentioning that in this case, I'm only talking about positive integer values for n. Let's solve these 4 exercises using these two equalities so we can practice a bit. First, let's notice that here in part A, we have an even index, so we're going to use this equality, right? In this case, it's telling me that what I have to do is take the absolute value of a. In this case, a is 4, so I would have the absolute value of 4, which is equal to 4. All right, let's move to part B. We have the 6th root of negative 4 to the 6th power. Here, n is even. So what I have to do is use this equality that tells me what I should write. The absolute value of negative 4. But the absolute value of negative 4 is equal to 4. Let's continue here. See that I have the absolute value, but the absolute value of negative is equal to 4. See that here I have the absolute value of negative 4, but it's the same. Ervis alert not is not for Enkistlov to disappear. It's happening because of envy, Rusu. 4. Easy, right? Let's see. Let's quickly check with the calculator, because we need to make sure that what we've done is correct. All right. Let's put the calculator here. Press Shift, and then on this button, we enter the number 6. We move with the arrow, and we're going to enter 4, raised to the 6th power. We executed it, and it's showing 4 as the result. We're doing well. I'll move the arrow slightly and change it. Now I'll enter -4 instead of 4. So I open parentheses, put the minus sign, move with the arrow, and close the parentheses. We have this operation already, right? We hit execute, and it's telling me it's 4. We're still good. Come on. Now let's go with this other one, which is the 5th root. Sorry, 4 to the 5th power. So I'm going to move forward to be able to change that 6 to a 5. I move over. I'm going to remove the negative. I'm going to remove it right away too. The parenthesis is already there, and we'll change the 6 to a 5. Done. This here has to give 4. Let's see. Yes, it gave me 4. And finally, it's nearly the same, but this time with a -4. So I move over, open parentheses, put the minus, move over and close. Parentheses. This should give me -4. Let's see. Notice that it did give me -4. Does this mean then that what we did correctly? I'll give you 4 exercises to practice, but actually, I only gave you 3. The truth is, they're a little bit complicated, but basically, they're solved the same way I already showed you. So, please do them in your notebook, and when you have the answers, put them down here in the comments. I'll be giving a heart to the people who get it right. And well, that's it for today. I hope the video was helpful for you, but most of all, that you enjoyed it. See you next time. Take care and behave. Bye-bye.